Let's go over some examples of computing derivatives and learn some new techniques. Start with the following. If you have y equals square root of x times x minus x cubed, how might we compute the derivative of this function? Using the tools that we already have, one thing you can do is a little algebra first, which I would advise, and multiply the x to the 1/2 through. When you do that, you add exponents. So it's x to the 1/2 times x to the first. That's x to the 1/2 times x to the 2/2. I'll write it out so you can see what I mean. It's x to the 1/2 times, this is x to the first, but in preparation to add exponents, it's good to make it 2/2. And similarly, if we have x to the 1/2, then this is going to be x to the, you want to get your common denominator, 3 is 6/2. And so a little algebra gives us this is x to the 3/2 minus x to the 7/2. And now we can just simply apply the power rule for polynomials. And so we can say y prime equals 3/2 x, well, subtract 1, that's subtracting 2/2, and you get x to the 1/2 minus 7/2 x, subtract another 2/2, and you get 5/2. Okay? So multiply through if it is going to make your life easier. Similar type. What if we have the function f of x equals, let's say we've got an 3x squared minus 1, but it's all over x. How do we tackle this one? So once again, you can do some algebraic simplification. And you could write, okay, this is equal to f of x, you split it, it's like reverse adding of fractions. So this is going to be equal to 3x squared over x minus 1 over x. And that's going to be simply 3x minus 1 over x. And now we can take the derivative, and we get, derivative of the first one is just 3, derivative of the second is negative 1 over x squared, because it's x to the negative first, right? And negative 1, x to the negative second, and so you often see it written like that. Okay, so we could tackle these two problems using the techniques that we already have. What about the following? Let us consider g of x equals x squared times e to the x. Okay, so we've got two different functions sort of combined into one, and we know the derivatives of these separately, but that doesn't tell us how to take the derivative together. So what we need is something new. And what we need here is the product rule. So what's the product rule? The product rule says if you have two functions, f and g, and you take their derivative, okay, like here, the solution is the derivative of the first times the second plus the first times the derivative of the second. Okay, this is the product rule, very important. You will eventually memorize it, and so we need to use this to solve this one. So the derivative here, g prime of x, okay, so let's use the formula. Derivative of the first term is 2x times the second term, g, plus, we just take the first term, times the derivative of the second, well, it's e to the x, right? Because the derivative of e to the x is e to the x. You can leave it like that, or factor out an e to the x. Okay, so the product rule is very useful. Now, let's look at another function, say that we want to take the derivative of, and let's go with h of t equals let's do the cosecant of t. Okay, so this is a trig function, and I can tell you, I don't have this one, well maybe I do at this point, but I often haven't had this one memorized. And so let's just state what we know h of t can be written as cosecant as 1 over the sine of t. Okay, we know what the derivative of sine of t is, but what about 1 over the sine of t? The alternatively over here, what if we had an e to the x in the denominator? You can't like really kind of cancel it. You actually need another rule. We've got the product rule, we also need the quotient rule. Okay, so there's another rule called the quotient rule. And it says if you've got f over g, and you want to take the derivative of f over g, this is what you end up with. Starts similar to the product rule. So it's f prime g, but then it's minus f g prime all over g squared. Okay? So this is the quotient rule. And it's needed if you have a quotient that you cannot simplify otherwise. You have, well, sine of t is not like sine of t to the negative first, and it is, but we need something different to do that because in that particular case, it's not just a variable that's going to a power, so later for that one. But we can use the quotient rule to get this. So let's apply it and see what happens. Okay, so h prime of t equals what? Derivative of the first term is derivative of the numerator, which is actually 0, so that f of g goes to 0. We're just left with what? Minus 1 times the derivative of the second term. Derivative of the sine is cosine. Okay, so this is cosine of t, positive, and it's all over the denominator squared. So this is actually correct, but you will see it written in a different way. So just to show you h prime of t, well, you can split the sine into 2. Right, so you can rewrite this as negative 1 over sine t, and then times cosine t over sine t. And now we have two separate trig functions. And what are those? 1 over sine is actually, we just had it, right? It's negative cosecant. And then this is, cosine over sine is cotangent, okay? So it's cotangent of t. So what we've done here is we have used the quotient rule to basically derive what the derivative of cosecant of t is, knowing that it's defined as 1 over sine, and knowing the derivative of the denominator and numerator. Okay, so you can use the quotient rule to actually derive some of the other trig functions like cosecant and say secant, even cotangent. Okay, so let's maybe do another one, and let's see what formula we need to apply. Okay, let's try the following. How about FGH, how about S of t? Okay, so S of t is going to equal what? Let's try x e to the x minus about 3 all over, let's change it a little bit, let's do a little more, 3 cosine of x all over x cubed. Okay, so this is sort of a complicated expression, but it's clear sort of from the dynamic that it's set up as a quotient. Now the x cubed could cancel out one of the x's here, but then you'd be left with another one there on the right side, so we're going to have to use the quotient rule. Okay, so what is s prime of t? Okay, so we've got to take the derivative of the numerator. Okay, right, the whole numerator. There's a lot going on there. Well, for this f prime, we need the whole numerator, and this is a product. So we actually need the product rule within it. So what's the derivative of x e to the x? It's derivative of the first, which is 1, times e to the x, plus it's just x e to the x, because it's the first term times the derivative of the second, but it's nicely e to the x. This e to the x is really nice to have. Okay, so that's the product rule on x e to the x, similar to x squared e to the x. Now what about the negative 3 cosine of x? Okay, that is, derivative of cosine is negative sign, so we get a pot and the 3 just comes out. So it's plus 3 sine of x. Now, all of this is just f prime, okay? So this is also times g. G here is going to be the denominator, which is x cubed. Okay, so that's that f prime of g. But then we need to subtract what? F. Okay, f is now the whole numerator. So it's x e to the x minus 3 cosine of x. Okay, so that's our f right here. And then times g prime, which is just 3x squared. And that is all over simply the denominator squared, and that is x to the 6th. Okay, so that's the product rule and the quotient rule. And I will say this, when it comes to the quotient rule, I'm just going to leave this last one as is because it is, well, maybe I can show you something. It's complicated as it is. When you are looking at simplifying the quotient rule, generally speaking, you're looking to see if are any terms going to cancel in the numerator. I don't think so here. Like we have an x, 2x e to the x's, but one of them has an x cubed and the other has a 3x squared. Okay. However, the e to the x, x cubed, and this would be negative 3x cubed e to the x, those could combine. Something else is the denominator. You want to try to cancel the denominator with one of your other terms in the with both sides of the numerator. So it's good to keep it in factored form because we can see actually, oh look, I can factor out x squared from everything. And when I do that, that goes away. This becomes just an x. I'm left with x to the 4th down here. Okay, so that's one simplification, and that simplifying the denominator sort of makes simplifying the numerator a little bit easier. So look out for simplifying the quotient rule, and you'll be using the product rule and the quotient rule often to help you take derivatives.